There is a machine sitting somewhere under the ocean right now that cost about $3.5 billion to build. And the most expensive thing engineered into it does nothing you can see. It can't be flyered. It can't be flown. Its only job is to make this machine impossible to hear. This is a nuclear attack submarine. 8,000 tons of steel, as long as a football pitch. It carries its own power station, a nuclear reactor fueled once, that never has to refuel for the entire life of the boat. By every obvious measure, it's a monster. And so you'd assume the bill is a monster too. That you're paying for size, for speed, for power. But walk along the hull, and the first strange thing you notice is what's missing. No rivets, no glint, no noise. The most advanced machine a navy can build is engineered, above all, to be unremarkable, to not be there at all. So where do the billions go? Start with the steel. This isn't ordinary steel. It's a special high-yield alloy, formed and welded to survive being crushed. The deeper the boat dives, the harder the entire ocean squeezes it. And every weld on a submarine is inspected, one by one, because a single bad seam can sink the boat. There are no second chances at depth. So the steel is formed to fractions of a millimeter, rayed, and signed off seam by hand. That makes the hull slow and painstaking and expensive. Months of work go into a structure whose entire job is simply to hold its shape while the whole weight of the ocean tries to fold it flat. The pressure hull alone, the part whose entire job is simply to not be crushed, runs to an estimated $700 million. Then there's the heart of it, a nuclear reactor, shrunk down to fit inside a tube. It turns a tiny amount of fuel into years of power, enough to drive the boat around the planet without ever surfacing for air or fuel. This is some of the densest, most safety, critical engineering ever built. It's fueled exactly once, sealed, and it runs for decades. No fuel stops. No supply line. And there's a quiet reason that matters for our story. A boat that never has to surface for fuel is a boat that never has to be seen refueling. The engineering that keeps it powered and the engineering that keeps it hidden are the same idea. Wearing different clothes. The reactor and its plant, an estimated $900 million. Nearly $1 billion for the power to stay hidden indefinitely. Natural pause Y400 target, placed at the pivot into the hidden cost. And now we reach the strangest line on the entire bill. Because here is where the money stops buying things you'd expect and starts buying silence. Look closely at the skin of the boat. It's covered, completely covered, in tiles. Rubber acoustic tiles, placed by hand, one at a time. On a British Astute class submarine, there are reportedly around 9,000 of them. Each one has a single purpose: to swallow sound. They absorb an enemy's sonar ping, so almost nothing bounces back. The way the foam, on a recording, studio wall eats an echo. And they trap the boat's own noise inside, so it never escapes into the water. 9,000 small acts of disappearing, glued to one hull, one tile at a time. Think about that as a manufacturing problem alone. Every tile cut, shaped, bonded and checked, across a surface the size of a city block, on a curved steel skin. And if even patches of them peel away in service, the boat starts to be heard again, but the tiles are only the outside. Inside, the entire engine room is lifted off the hull and floated on a raft of mounts, so that not one vibration from the spinning machinery can travel through the steel and into the sea. Pumps, turbines, Generators, anything that turns or hums, is cushioned, isolated, decoupled from the body of the boat. The crew even trained to move quietly. The boat is, in effect, holding its breath. Constantly. Every system on board is judged not only by whether it works, but by how little sound it makes while working. And at the very back, the part they won't let you photograph clearly. Not a propeller, a pump jet. A shrouded propulsor whose exact shape is one of the most closely guarded secrets on the boat, because its only job is to push thousands of tons through the water without making the tail hiss that gives every other vessel away. Add it together, the tiles, the rafts, the secret propulsor, and you reach an estimated $800 million. Close to $1 billion. For nothing you can fire, nothing you can see. $800 million spent entirely on not being heard. And once it's silent, it becomes something else, an ear. The bow, the flanks, a long array trailed out behind. The boat is wrapped in sonar. The whole philosophy snaps into focus. Be silent, so you can listen. It hears everything, and the ocean hears nothing. The sensors and combat systems, an estimated $500 million, to turn invisibility into an advantage. Natural pause while 6730 target. Then there are the years. A submarine like this takes the better part of a decade to build. And at the end, it's run across acoustic test ranges, where engineers measure exactly how quiet it managed to become. Assembly, integration and testing, an estimated $600 million more. Much of it spent confirming, over and over, that it disappears. So let's answer the real question. What does a nuclear submarine actually cost? Around $3.5 billion to build one boat. And here's the part to sit with. The most expensive engineering inside it. The tiles, the rafts, the pump, jet, doesn't make it faster. Doesn't make it stronger. Doesn't fire anything at all. It buys silence. 7,000 tons of steel, a power station and a crew, engineered, at the cost of nearly $1 billion, to slip into the ocean and sound quieter than the water around it. That is the hidden cost of a nuclear submarine. You assume you're paying to be feared. You're paying, more than anything, to vanish. $3.5 billion. Spent on homes. That's somewhere around 8,000 to 9,000 houses, a whole town. Traded for a single boat you will almost never see. And the comparison the Navy itself likes to make is even stranger. They've described their quietest boats as harder to hear than the sea itself. One was compared to the sound of a baby dolphin, a machine the length of a football pitch, with a nuclear reactor inside, made to register as less than the noise of the waves. That's the thing about the most advanced machine a Navy can build. The number you'd guess, the size, the speed, the weapons was never the real cost. The real cost was the silence. Almost $1 billion spent so that thousands of tons of steel could move through the ocean and leave no sound behind. That's what we do here. We find the bill that isn't on the receipt for the things you thought you already understood. Next time, the shipping container, the cheapest looking object on Earth, and the reason almost everything you own crossed an ocean for pennies. This was Cost Atlas, the hidden cost of everything. See you in the next one.